Hello?
Yes. What do
You
you
know
mean average?
the average
Average for
score.
what?
Yeah, the average score of this class.
Average score. That one I not analyzed yet.
Oh,
But
okay.
so far, the highest is 25. I think Dominic, isn't it? Mm,
Oh shit. Oh,
Dominic,
stop.
the highest one. 7 plus 3 is 10 plus 15, 25. Yeah. But the overall is quite good lah. I think okay. You need to score test 2.
Is test 2 easier?
Yes. I
Seriously?
can say easier than test 1. But test 1 also, I how to tell this? Um, if you do like a sequence D, like what we have learned, then you may do it well if you follow. But uh, as I observe from the answer script, your paper, I can say that uh, most of you are influenced by the others your classmate, your friends. You are not sure about your answer, and you try to look at or see the friends, and then you might got confused with your own answer. And supposedly, if you follow the lecture, and then you can do it well, because they have one student. She did very well because she followed every single thing with sequentially organized find number of mole, and then follow the concept, the right concept. Like the question number 1, most of you write the answer for the appearance, physical appearance, isn't it? Please read question carefully. Physical appearance and physical properties. The appearance of physical properties not seen. With physical appearance, yes, you can give the answer in terms of solid crystalline, a solid crystal. But in terms of physical properties, the appearance of physical properties, that's different. You may check your answer script and then let me know if you are not satisfied with the marking scheme, and we'll discuss, and then I will rewrite the marks before we send to the TFS office. Okay, we settle down after we finish chapter 11. Alright, are you with me?
Yes, yes, Miss.
Okay, I hope that you check your marks. Oh yeah, this one we forgot 25, is it?
What do you mean, Miss?
Ami Wafi sent a picture. Who is this?
Oh, oh, that's not Dominic.
Um, okay, we start our lecture, chapter 11. Chapter 10. Continue chapter 10. Okay, chapter 10, we continue with exercise 10.5. Last week, I asked you to do the exercise 10.5. Have you done? If you done exercise 10.5, 10.6, the answer is provided here. Okay. I discussed with you lah. Okay. A gaseous mixture made from 6 gram of O2 and 9 gram of CH4 gas is placed in 15 liter of vessel at 0 degrees Celsius. What is the partial pressure of the gas for each O2 and CH4, and what is the total pressure? Okay, to find this, you are given the mass. You can find mole, and then a volume, and temperature. Okay, you calculate for each gas. O2 is given mass equal to 6 gram, and then find number of mole. 6 divided by 2 times 16, oxygen 16, 2 atom O, and then we get number of mole 0.1875. Then use okay, volume is given 15 liter and also temperature 0 degrees Celsius. Okay, you need to change all the units, degrees Celsius to Kelvin, which is 273.15 Kelvin, and liter is in liter and mole is mole, because we use R value is 0.0821 ATM liter over mole Kelvin. Then you need to change all the variables into unit. Okay, after we got all the information for O2, then we can calculate the pressure. How to calculate the pressure? We use PV equal to nRT. So here, pressure for the gas O2 is equal to nRT over V. Okay, number of mole you calculate from here, 0.1875 mole. R value we use 0.0821 because we want to get ATM liter over mole K. ATM you need to send the unit here, mole. This is temperature in Kelvin, 273.15 K. Here is K, so we change to Kelvin, over volume liter, in liter 15 liter. Then we get the partial pressure for oxygen is equal to 0.281 ATM. Liter cancel out, and then Kelvin, mole. Then left is ATM. Right. For the CH4 also give you the mass. Mass is 9 gram. How to find mole? Mole equal to mass divided by molar mass 12 plus 4. Then you get the number of mole for CH4 is 0.5625. PCH4, same thing, you use PV equal to nRT and nRT over V. Okay, so number of mole 0.5625 times with 0.0821 times with temperature 273.15 Kelvin, then divide by volume is 15 liter. You get the answer, which is 0.841 ATM. Okay, so what is the total pressure? How to calculate total pressure? P total equal to P oxygen plus P CH4. Partial pressure for oxygen and partial pressure for CH4. Then you get the answer, which is 1.122. Okay, follow this sequence here. Number one, number 2, and number 3. First, find each partial pressure for oxygen and HCH4. Then you get the total pressure. That's it. Okay, then next 10.6. Synthetic atmosphere composed of 1.5 mole percent CO2, 18 mole percent CO2, and 80.5 mole percent ER. calculate the partial pressure of O2 in the mixture of if the total pressure of the atmosphere is 745 torr. Okay, so O2, how to calculate partial pressure for O2? O2 is given a number of mole. Oxygen number of mole is 18 mole. Okay, and then we use formula PO2, partial pressure for oxygen is equal to mole fractions of oxygen times P total. Yeah, because you are given the total pressure, the total is 745 torr. How to calculate the mole fraction for O2? Mole fractions for O2 is equal to 18 divided by 18 divided by, you need to add all the gases lah. The O2 1.5, O2 is 18, the number of mole of the R is 18.5, so you add all this. 18 plus 18.5, then you get the answer. Okay. Did you get the answer, class? Here is my calculator. Okay, so 18 divided by 100, then we get 0.18. Mole fraction 0.18, then we substitute into this formula. Need to change P total equal to 745 torr, right? So that okay, no need because the we can leave it in torr because we are not using R 0.0821, so just P of 2 equal to 0.18 times with 745. So you get the partial pressure for oxygen 134. Okay, for B, if this atmosphere is to be held in 120 liters space at 295, how many mole of O2 are needed? Okay, so we have the pressure 134 torr, and then volume is 120 liter, temperature 295 Kelvin. Okay, then we have the variables pressure where volume and temperature, use PV equal to nRT. Then find N equal to PV over RT. Pressure, because R in 0.0821 ATM, so change it to ATM. 760 divided by 134, then you get the pressure in ATM 0.1763 ATM times with volume 120, 0.0821, then temperature is 295 Kelvin, then get the answer. So directly you get the answer 0.874 mole. Any question?
No, miss.
Okay. Alright, we continue with the kinetic molecular theory. Kinetic molecular theory seems like the one we learned in secondary school, which is the collisions, about the collisions. So this kinetic molecular theory was proposed by the Rudolf Clausius, which is lead to the four laws, which is Boyle's law, Charles' law, Dalton's, and Avogadro's law. So from this kinetic molecular theory, which is the theory of moving particle, assumptions was made. There are few assumptions. The first one, gas is a discrete molecule, isn't it? So when gas consists of larger number of molecules in constant random motion. This is assumption. First assumption about the gas. Gas is a discrete molecule. It moves in constant random motion, which is in continuous or straight line motion with varying the velocity. That's the first assumption. And second, the volume of individual gas is negligible. Assume as very small. Negligible, we can assume as zero lah. Very small. So if we compare with the volume of the container, then they have the total volume. If individual molecule, it is negligible, but compared to the volume of container, they have a total volume. That's second assumption for molecular theory. And next is about the attractions and the repulsion force, which is the intermolecular forces between gas molecule are negligible, but it might affect if they at different temperature. That means temperature will affect the intermolecular forces. We'll look at after this. And next assumptions, the collisions between the molecule, which is perfectly elastic. The molecule with the wall of the container, it collide with perfectly elastic. Means that the average kinetic energy does not change. The total energy is conserved, like no net ionic, no net energy gain or loss. So gain or loss of energy, there is the total energy is conserved, so no net loss or gain of energy. That's number 4. And next is the average of kinetic energy of the molecule is proportional to the absolute temperature. Absolute temperature, it is the real temperature. So for this absolute temperature, we must use in Kelvin, unit in Kelvin. Okay, so average kinetic energy is proportional to the temperature. So temperature affect the kinetic energy, the movement of molecule. What happen if we have the different temperature and also different gases in one container. Okay, this graph show the molecular speed of molecule. Okay, here are the number of molecule. This is number of molecule, and bottom here at x-axis is speed. Okay, at 273 Kelvin, which means at 0 degrees Celsius. 0 degrees Celsius, the 273, not the 0 degrees Celsius, 25 degrees Celsius. Negative 273 is 0, so 273 is 25 degrees Celsius, isn't it? 0 plus 273.15. So 0. Okay, at temperature 273 Kelvin or 0 degrees Celsius, we can see that the molecule, many of the molecule moving at speed, let's say around 500 meter per second. Okay, so many of the molecule move at 500 meter per second at 0 degrees Celsius or 273 Kelvin. And as we increase the temperature, let's say around 2000 here, 2000 degrees Celsius or 22730 Kelvin. So even many molecules move at the speed of 1500 meter per second. So many molecules are moving with the speed 1500 meter per second at 2000 degree Celsius. So temperature affect the movement or kinetic energy, the average kinetic energy of the molecule. It's proportional to the kinetic energy proportional to the temperature. Okay. Alright. So here are the average kinetic energy mu. It is related to the root square speed u. U is root mean square, which is RMS. We call it RMS, and the mass as well as the mass. So we're using this formula. Let's say we have the molecule, gas molecule He, gas N2 gas, O2 gas. So at same temperature, He is lighter gas. So the movement, the average velocity is higher for He due to the lower mass, lower molar mass of the He compared to N2 the NO2. So we can see this from here. The gas composed of light particle like helium, just now helium, will have the same mu as the composed much heavier particle. Here given as E, but I give you example N2 and O2. So molecular kinetic energy of gas increase with increasing the molecular weight and temperature. So lighter the gas means that mass of the lighter gas is less compared to mass of the heavier gas. Thus, lighter gas like He will have higher RMS speed, which is U, compared to O2. O2 around 2 times 16, 30, approximately 32. So much heavier compared to helium. That's why lower RMS value speed. Okay, so the mass M of the lighter gas is smaller than the heavier gas. Therefore, the lighter gas they have higher RMS value. And then from the speed RMS, U equal to 3 RT over M. This is the formula. You must remember this formula. This is how do we get this formula? It is very long derivations. Very long derivations to get this formula. But you just remember this. U equal to 3 RT over M. And RMS is inversely proportional to the molar mass. U inversely proportional to 1 over square root of M. Okay, so consequent of the dependence molecular speed by mass, we have two types of movement of the gas molecule through the efficiency and diffusion. So we know that gas move in a constant motions, rapid and random motion, so it will diffuse quickly through a container. So how do this gas diffuse? It has two types of two types of movement, diffusions of the gas. First one is efficiency. So what is mean by efficiency? Efficiency is the escape of gas through a tiny hole. Example of smell of rotten egg. Okay. Smell of rotten eggs released when put in a larger room. So the odor can eventually be detected, isn't it, through the room. So that this is kind of example efficiency. Efficiency is diffusion of gas through a tiny hole. While for the diffusion is the spread of one substance throughout a space, like perfume. Perfume, it will diffuse from room A to room B, from room B to room A. That's diffusion. Okay. Okay, look at the for efficiency. Efficiency rate of a gas is inversely proportional to the square root of its molar mass. So R is rate of efficient rate, inversely proportional to 1 over square root m molar mass, inversely proportional to the square root of molar mass. So let's say we have gas 1 and gas 2 here. Gas 1 and gas 2, they have different molar mass M1 and M2, as well as different rate of efficiency R1 and R2. Thus, we can write the R1 over R2 equal to 1 over sec m 1 over 1 over sec m squared. Then we get divide times, so we get sec m squared over sec m1 R1 over R2. That's how we get this formula. Okay, so still efficient. Lighter gas fuse more rapidly, which is escape more rapidly compared to the heavier gas. Lighter gas like helium will escape quickly higher compared to the example O2, because O2 is heavier. Molar mass is larger compared to He. So only those molecules which hit the small hole will escape through it. Like the gas molecule, when it collide with the wall of the container, then it will escape through a tiny hole. This, the higher the RMS, lighter the molecule, lighter the substance, it will have higher RMS peak. So the greatest possibility of gas to hit the hole and be fused. Higher the RMS peak, more tendency for the gas to hit the hole, the wall of the container, and thus it will diffuse out through a tiny hole and spread throughout the entire container room. Okay, so you can set from the equations U RMS equal to set R 3 RT over M, right? This is formula for U. And this, we can say from here, higher the speed, then we can relate with the molar mass. This is RMS speed. Just now we have the formula, right? Okay. Now, still efficient. Okay, how do we get this formula? From R, which is R is constant, U is RMS speed, so R1 over R2 inversely proportional to the U1 over U2. Okay, so from here R1 sec M squared over sec M1 equal to 3 RT over M1 divided by 3 RT over M2. This cancel out this 3 RT. We get M2 sec M2 over sec M1. So this is constant, basically same. That's why R is constant U. This is R and this is U. Same thing. If they are efficient, directly proportional to RMS speed.
Miss,
Yes.
what's R again?
Okay.
Miss,
Yes.
R.
R. What is R?
Yeah, what's R? What's it supposed to?
Oh, R is rate of efficient.
Okay, thank you.
Okay. U is the RMS speed. How do we get this R? How do we get this set M2 over M1? Because R is directly proportional to U. This means that this R and this U is equal, M squared over M2 over M1 set. Right, so that we get this one. Okay, now for diffusions like efficients, the delta D, the average distance. Okay, but the molecular collisions for diffusion is quite complicated, and that but we can observe the average distance is equal to the mean free path (MFP). What is mean free path? You look at this picture. From this molecule to this molecule, the distance here is delta D, which is we call it as a mean free path. So the higher density of the gas, smaller the density of the gas, smaller the mean free path (MFP). So the more molecule in a given volume will have the shorter average distance travel to the molecule with the lesser the collisions here. So this is the movement of the molecule, and average distance of movement here, we call it as a mean free path. Okay. There's the diffusions. Okay, so the deviations from the ideal behavior. Okay, as we know, under ordinary conditions, most gases do behave ideally, because ideal gas, the molecule are assumed to occupy no space and no attractions for one another. But the real gas, they have a finite volume, and then they attract to one another. That's the real gas. That's why at first I told you the real gas and ideal gas is not same. So you cannot use same formula, PV equal to nRT, because of the pressure and volume are well described in the real gas. Okay, so real gas it's postulate the kinetic molecular theory. The idea, the pressure and volume are well described by the ideal gas law. This is ideal gas law, which means obey the postulate of kinetic molecular theory. So at lower pressure, we assume normally it's ideal behavior. Normally ideal gas at lower pressure, which is below 10 atm. Okay, we see this picture. Okay, this is about the real gas and effect of the intermolecular attractions for the real gas. Okay, from here, if they have intermolecular attractions between the gas A and gas B, let's say gas A and gas B, if they have the this is gas molecule A and B, if they have the intermolecular force, the attractions, it will lesser the freedoms of gas molecule. So when less the freedom, it will causes less collision, isn't it? When less collisions of the molecule to the wall of the container here, so that means pressure will low. When pressure is low, volume also low. Okay, so that's why when we push this piston P at Z, when we apply the pressure, what happened to the volume? Volume become smaller, right? At first, volume is larger. So when we push the piston and apply the pressure, volume becomes smaller. So it will make the molecule near to each other. When near to each other, they will have the attraction force. The attraction force between the molecule, because near to each other. When they have the attraction force, they have a higher tendency to collide between the molecule and wall of the container. So for the applied pressure, for the real gas applied pressure, they have the attraction force. We need to consider the attraction force.
Miss,
This is the attraction force between the molecule and molecule. Yes?
if the attraction forces are stronger, right, does the pressure decrease?
Attraction force stronger.
Yeah, does the pressure decrease? Hello?
Hello? Yes?
If the attraction forces are stronger, does the pressure decrease?
Attraction force stronger. What
Yeah,
happened to pressure?
yeah.
Okay, if attraction force
What?
stronger, means that pressure is higher.
Okay, thank you.
Okay, so at this slide, at pressure increase, as pressure increase, we increase the pressure. This is for the ideal gas. So P ideal V over RT equal to N. N is equal to 1. This is for ideal. PV equal to nRT and N equal to PV over RT. Okay, N here is number of mole. If we have PV over RT equal to 1, this is obey the ideal gas. PV over RT equal to 1. Okay, so but the attraction force just now, the attraction force between the molecule becomes significant when we apply the pressure. So when we apply the pressure, we will affect the volume. Volume will decrease. When volume decrease, it will make the molecule close to each other and they have the attraction force. The attraction force between molecule becomes significant, become important. So that's why the pressure, the real pressure, the real pressure PATM less than PID. The real pressure is less than PID. Okay, from this graph, PV over RT, this is number of molecules. Okay, number of molecules is equal to 1. And this is behave the ideal gas, which means the ideal gas at all pressure. Okay, at all pressure, PV over RT equal to 1. What happen if we have the attraction force? So when we apply the pressure, it will have the attraction force, which is this one, less than 1. Because right now, the number of molecules is less than 1 because the effect of attraction force. Attraction force become dominant. And when we apply the pressure, P apply, it will have the attraction force, make the volume become lower. And more molecule near to each other make, and that's why P real is less than P ideal. Okay, so the behavior of the several real gas, this is non-ideal behavior of several gas. Right. So at PV over RT greater than 1, the effect of molecular volume, which is the what you call the weight of the gases itself, like CH4, H2, CO2, and He. This greater than 1, we will look at the effect of molar mass, molecular weight, the molecule. Mm, so the after the pressure, we have the temperature. The pressure that affect the gas. Okay, any real gas, the molecule can attract one another. So temperature determine how effective the attraction force between the gas molecule. How to know this? Look at low temperature and high temperature. Okay, at low temperature, the gas deviate from the ideal, which is the average kinetic energy will decrease. The molecule, when decrease, the molecule move slowly, move the movement of molecules slowly, very slowly, and then potential energy is dominant, will dominate in this low temperature. But at high temperature, the gas molecule are far apart, thus the volume will dominate, become important. So at high temperature, the potential energy due to the intermolecular force for the high temperature is negligible, which is very small compared with the higher kinetic energy due to the random or rapid motions of the molecule, and thus it will create a great distance between the atoms, between the molecule. So At higher temperature, volume also higher. When low temperature means that kinetic energy is low, then this potential energy become dominant. Potential energy become dominant due to the low movement of the molecule, which is or slow movement of molecule. That's and then the intermolecular attractions become constant or not does not important anymore due to the small remain constant or small intermolecular attractions. Okay. Okay, do you have any questions, class?
No, Miss.
Clear, Miss.
Okay, so okay, then we go to next slide, which is the van der Waals equations. Van der Waals equations is nRT over V minus NV minus N2N squared A over V squared. How do we get this? Because we minus the corrections factor, which is N squared A over V. Alright, so the ideal gas, how do we get the van der Waals equations? First, we need to know the ideal gas equations we cannot use to predict the pressure volume properties at higher pressure. So the ideal gas equations, we use this one, isn't it? The origin one. But these expressions were corrected by two effects, which is the first one, volume, and another one is the pressure, the attractive force due to the effect the pressure, attractive force between the gas molecules. So we have the P measured plus with N squared A. This is the corrections factor. N squared A over V squared measured. This is P and V measured minus NV correction factor equal to nRT. Okay, so from here we get this formula, which is the van der Waals equations. P equal to nRT over V minus NV minus N squared AVA. Okay, what is P? P is pressure, N number of mole, R is gas constant, T temperature, V is volume, N is number of mole, B and A is constant. Constant is given. This given in table here. This is constant for A and B. Okay. Constant for A and B for each gases, selected gas. Let's say Cl2 gas. What is A and B value constant? This is to correct the pressure and as well the volume, because these two factors affect the real gas expressions of PV equal to nRT. So NV is the corrections of finite volume of the gas. Okay, if we look at example. Okay, example here. Using the van der Waals equations. Van der Waals equations is given P equal to just now nRT over V minus NV minus N squared A over V squared. If 1 mole of ideal gas were confined in 22.41 liter or 0.0 degrees Celsius, what would exert pressure of 1 atm? So how to calculate this? we use pressure P equal to nRT over V minus NV lah. Just substitute into formula. N number of mole is given 1, and then R is constant 0. Value for R is 0.0821, isn't it? 0.0821 times with temperature is 273.15 divided by volume 22.41 liter minus with N is number of mole 1, B constant. Okay, for B, because we want to find the pressure exerted by Cl2, refer the value for Cl2 here. For B is 0.0562. 0.0562. Okay, then minus N1 squared A 64649 over volume is 22.4 squared. So we get the pressure exerted by Cl2 gas. This is the corrected formula when we have higher pressure. Higher pressure molecule will close to each other. As a result, it will have the attraction force. That's why we need to minus with the correction factor here. Minus with the correction factor. Okay, from these equations, just now P measured N squared A here. This is actually PV equal to nRT. We corrected this the equations, van der Waals equations, due to the higher pressure. We corrected with the P measured minus with correction factor, and then volume measured minus with the correction factor for the gas. Next example. Later you try to do this do by your own example, each example in this slide, and try to calculate and try to understand the equations. Right, example 17. Sample KClO3 is partially decomposed through KCl and O2. Collected over water. This is very important. Collected over water. The volume of gas collected is 0.25 liter. This is liter, isn't it? At 26 degrees Celsius and 765 total pressure. How many mole of O2 are collected? Okay, in order to find the number of mole of O2, we have the volume equal to 0.25 liter. Try to extract the information given. Try to come up with the information given, then you do the questions based on relevant formula, because we have a few formula in this chapter gas, right? So we try to come up with the informations. What else we have? P total, T total, the temperature, right? Temperature 26 degrees Celsius. 26 plus 273.15, then we get the Kelvin. This is degree Celsius, change to Kelvin. And once we have P total equal to 765. Okay, how to calculate the oxygen? You have three variables. Okay, gas O2 collected over water. So that's mean you need to minus this with the partial pressure of water. Check the partial pressure of water at 26 degrees Celsius. What is the partial pressure of water? If you search into the internet, then you get the partial pressure of water at 25 degrees Celsius is 25. So pressure for O2, you need to minus the total pressure. 765 minus 25 get the answer store. 2750. This is partial pressure for O2. Okay, 750. Then substitute into the formula PV equal to nRT. You need to find N, number of mole of O2. Okay, number of mole O2, PV over RT lah. Pressure is 750. Volume is 0.25 volume. And then divide by 0.0821. 750 into change to ATM means that 760 divided by 750, we got ATM, and times with 0.25 liter divided by 0.0821, ATM liter per mole Kelvin, times with temperature Kelvin, this one, around 299, isn't it? 299.15. Then we get the answer. What's the answer? What is the number of mole for O2? You get number of mole here. After you get number of mole, question B, how many gram of KClO3 will decompose? So how to know the mass of KClO3? Because we find the number of mole O2. So 3 mole, we write the equivalence stoichiometry equivalent. 3 mole of O2 equivalent to 2 mole KClO3. And then let's say X mole. So X mole divided by 3 times with 2, we get the number of mole for KClO3. And after we get number of mole, how to find mass? Mass equal to mole times molar mass for KClO3. Okay, when dry, what volume will be collected? O2 gas occupied at the same temperature and pressure. So how to calculate the volume? Use formula PV equal to nRT. What volume will collected O2 gas occupied at the same temperature? So you use PV equal to nRT or you use the Boyle's law, either one, you get the same answer. Okay. Same temperature and pressure. Okay, at same temperature, pressure means that constant. PV equal to nRT. I use the information given here. Pressure and temperature is constant. Same temperature and pressure. So, and use Boyle's law, P1 V1 equal to P T1. We need to PVT together. So P2 V2 over P2. What is the volume collected? V2. So V2 T2 P1 V1 equal to P2 V2 T1. Then V2 V2 equal to T2 T1 V1 over V2 T1. Then substitute formula and substitute the value, you get the answer. Okay, next we have exercise here. Okay, ammonium nitrate NH4 and O2 decompose open heating to form N2 gas. When sample of NH4 and O2 is decomposed in a test tube, as in figure here, around 511 ml of N2 gas is collected over water at 26 degrees Celsius. Okay. So what is the mass of NH4 and O2? Okay, first you need to come up with the data information given here. We have volume 511 ml. Okay, and then we have the temperature 26 plus 273.15 again in Kelvin. Okay, total P total equal to 745. P total means that with the N2 and water. So how do we get the PN2? Because we want to find the the mass for NH4 and O2. Here we have N2. Then we use information for N2 to find the number of moles. 745 minus water, partial pressure for water is 25. Then we get a 720. So okay, and find mole equal to PV over RT. The pressure change 760 divided by 720, you get in ATM around 0.947. Volume is 511 exponent negative 3. Remember volume in liter, so change milli 10 negative 3 to change to liter, become 511 exponent negative 3, or you can write 0.511 liter. Divide by 0.0821 times with temperature. Temperature is 26 plus 273.15, 299.15. Then get number of mole. Let's say X mole for N2. How to find mole for NH4 and O2? 1 mole N2 equivalent to 1 mole NH4 and O2, isn't it? From decomposition reaction here, NH4 and O2. So that means mole for NO2 is same like the mole of N2. So X mole of NH4 and O2 Y. Okay, then you can find the mass equal to mole times with molar mass for NH4 and O2. Okay, you get the answer. Alright, that's all for chapter 10. Do you have any questions?
Nope, no questions, miss.
Are you okay? Kenapa senyap pula? Tadi
Yes, miss. Focus.
ke kecewa?
Wah, kecewa.
Or you disappointed with the result? Test
No
9
lah.
chemistry.
Maybe.
Focus, miss.
Okay, can we continue chapter 11?
Break.
5 minutes. 10-minute break. 10-minute
10
break.
minutes. Lamanya 10 minutes.
Yeah.
9 minutes.
Okay lah, 10 minutes break.
Thank you, Miss.
Right. In the meantime, do you have anything? Any questions? Let me start share first.
Attendance.
Do you have any question? I can read your message. You may ask anything. I try to answer. Saya tak ada mouse lah. Mouse saya rosak. Okay, let me okay, Africa, this X stand for what? What X? X for what? What is X? Where X? Yes, R is constant. R is gas constant. Remember, R is gas constant, and always keep in mind that R unit for R is equal to ATM liter over mole Kelvin. So make sure all four variables you need to change into this unit like R gas constant value. Because we use 0.0821. I always mention that thing. That's very, very important in gas. R, value for R. Follow the units of R, not anything else. Just a few we deal with the joule, but the most of the time we use 0.0821, which means the unit is follow that mole ATM liter over mole Kelvin. What is the answer? Answer for what? Example 16. Answer for example 16. You don't have the answer? Example 16. Try to do the example 16. Then you've got around 0.99 ATM. If you got in that range, so that means doesn't matter. It's okay as long as you follow the concept, the rule. The concept is correct, then your answer should be okay. No problem. Wait. Okay, Ahmad Afzal. 765 minus 25. Okay, we minus this 25 because of partial pressure of water constant. You try to Google partial pressure for water at 26 degrees Celsius. What is the value?
Wait, what do you say, Miss?
I try to answer your question one by one. Our normal final exam, if our final normal exam, do they give the formula? Okay, this semester we have extended assignment. So basically the questions is given. If questions ask you about the let's say about the topic gas, means that it need to provide all the constant value. Okay? Don't worry, all the constant we are provide to you, and as well as you can Google during the exam, isn't it? You try to find out in the internet sources. Maybe you got lucky and then you got the answer. Okay. Try. That's your effort lah. Oh, we need to memorize everything. Yes, you need to memorize if we have the face-to-face final exam. But like now, this semester, we have extended assignments so that you may do it in your room or in your at your home. So it doesn't matter. If you want to memorize, that's good. If you can't memorize everything, then just know how to do it. Then that should be better. We have where um, Miss, can we have an example question which can relate to the test too? Yes, I try my best to do the exercise that relate with test two. And I if we have time, I will have another extra class for you so that we can discuss the exercise. Maybe on Thursday night, I try to finish with the exercise that related to the test two, and then we discuss together. I combine you with the other class, class EE. 1 hour, around 1 hour only. I might took 1 hour. Don't worry.
Okay, thank you, Miss.
But that one is not being recording. There is no recorded for that session, because that one is the extra from me to all of you. So I want to help you. This is between us, between my class only.
When is it, Miss?
Thursday, this Thursday,
Okay,
Thursday night.
okay. Thank you.
Okay, I will let you know about the details later if they have any changes.
Okay, thank you, Miss.
Yeah, because what we had learned is the in lecture and what has that one normal lah. Big Ahmad Afzal, that one normal because uh, how to say this? If we give you exactly same like the lecture note, and at the same time you can search into internet, books, open lecture note. So how to say this? Where is the difficulties, isn't it? So we need to balance lah. We give you the what, the learning, and as well as we want to see the outcomes, the efforts as well from you. I can say that for question one, example question one, test one, you may Google tau, you boleh Google, then cuma soalan kau you confuse with the questions, appearance of physical properties. Appearance of course lah, we might to think about the solid, liquid, isn't it? But please read question carefully. Physical properties, not the physicals only. I try my best. Doakan saya sempat buat soalan. We discuss on Thursday night. Overall, your marks ME class, how to say this?
Very average.
The others class also the same like yours. So average for me, I can give you a quite good. Average is quite good. None of you got 0. And yeah, I quite surprising that thing, and very surprising, because I'm hear about the other lecturer told me that his student, a few of his student got 0. So I that's why I quite surprised about my class, two of my class. You perform well. You perform very well. So keep that momentum for test 2 also.
Thank you, Miss.
Yeah, that comes from your effort as well. Doa jangan tinggal, doa banyak-banyak. Okay? Tak ada soalan dah. Kita hanya mampu berusaha. Yang selebihnya kita serahkan pada sebab tu kita kena berdoa. Okay.
Miss,
Yes.
Iza is asking if we can have previous test questions.
Pardon? Nikita, can you repeat your question?
Ish, someone mutes me. Iza is asking if we can have past year questions.
Ask your question for
Chemistry
uh,
to practice.
yeah, that one I try to discuss with you on Thursday night.
Okay. Oh, okay. Thank you.
Miss, hi.
Yes.
About question Nikki just asked just now. I mean, test question from previous year or previous semester.
Test for test 2.
Complication of question.
Test 2, isn't it?
I mean, previous test question from previous year or previous semester.
Yeah. I tried like this. I tried to extract all the past year test 2 that relate with coming test 2 this semester. Is that okay?
Okay, thank you, Miss.
That one is my bonus. I try to help you. I hope that if we have enough time, so we can done with the extra classes, then we see the result. I hope all of you got a higher score for test 2. And one more thing, please, you are given 2 hours, isn't it? 2 hours, so make sure within 2 hours you need to submit. This time we are not give you any excuse or submission through email, cannot. We only accepted the manuscript from your script from ULearn only. So make sure you submit before times end. So make sure submit before times end. And do not disturb by the others thing. Please focus and just follow what you have learned. Test 2, I have given to you the hint, isn't it? I have given to you the hint, right, for test 2. If you follow all the class, you can do it for test 2. Very direct to the concept what we have learned. The ionization energy, the Born-Haber cycle. Ionization energy, you need to well known what is mean by the ionization energy in terms of why we cannot remove example group 1 group 2 one only, group 2 if we remove first electron, the energy is lower compared to if we remove a third electron because it's involved another subshell, is it? you explain in terms of that one lah. And then please conclude why the difference of energy quite high or quite huge between this transition between IE1, IE2, IE3, and conclude what is the answer. And for Born-Haber cycle, Born-Haber cycle, I have given to you the exercise. Make sure you do all the exercise, understand well the exercise. And okay, for the chapter gases, keep in mind always use PV and RT, and then just based on the questions, extract what formula you need to use. You can use PV equal to RT or voice P1 PV over T or PV over PV equal to PV1 over equal to PV2, but make sure you find every single thing correctly so that the final answer should be same, don't worry. And we apply a big concept of the empirical and molecular formula in gases. So make sure you follow the instructions given in questions. And for the molecular geometry, you need to identify what is the geometry of the molecules given. Okay, and the chapter 11, so chapter 11 focus on the types of intermolecular forces and phase diagram. That's it. I try to find out all the exercise related to the test 2, and I will discuss with you on this Thursday night. InsyaAllah. I doakan saya tempat buat. Alright, can we continue with the chapter 11? Only I try to take only 15 minutes so that we, because right now it's Maghrib already. Okay. Ada soalan lagi? Dominic, what do you mean 7-11? Test 2, what chapter cover? Test 2, we cover chapter 7, chapter 8, 9, 10, 11. 5 chapters. Oh, yeah, Dominic told the chapter, right? Chapter 7 to chapter 11. Okay, can we proceed, class?
Alright, yeah, we can continue.
Are you okay?
Yes.
Yes, miss.
Yes, miss.
We continue first, huh? Later you may ask the questions. Chapter 11. Okay, can you see the slide? Chapter 11. Can you see slide, class?
Yes, miss.
Okay. Chapter 11 is the intermolecular forces. Inter means that in. Inter means that between the molecule, like CH4, CH4. So between the molecule, they have the intermolecular forces. If intramolecule, this is intramolecule. Intra, in the molecule, like C and H, they have covalent bond, which is the strongest bond compared to the intermolecular forces. Intermolecular forces, we have 4 types of intermolecular forces: ion dipole, dipole-dipole, hydrogen bond, and London dispersion force. Only 4. And then we compare between these 4 forces. Okay, then we will look at chapter 11, liquid and gas, liquid and solid. Just now, chapter 10, we focus on gas, only for the gases. Then chapter 11, bit about the liquid and solid. Okay, content for chapter 11, first is introductions to the molecular comparison, state of matter, solid, liquid, and gas. Okay, then types of intermolecular force, we have 4, 1, 2, 3, and 4, and this comparison. Okay, then properties of liquid. Liquid is viscosity, the viscosity of liquid, and surface tensions about the liquid. And phase change, phase change in terms of energy change, and as well as the phases changes, solid, liquid, and gas. What happened to the energy? Solid to gas, the energy, delta H, enthalpy. And cooling curve, critical temperature and pressure, the vapor pressure, and last one is phase diagram. Phase diagram, we have two, CO2 and water only. Okay, finally, bonding in solid. Bonding in solid, we look at in molecular solid, covalent solid, and ionic metallic solid. Okay, objective, this chapter 11, first you are able to differentiate 4 types of intermolecular forces. We call it as a IMF. We have 4 types: ion dipole, dipole-dipole, London dispersions, and hydrogen bond. Okay, then you are able to relate this IMF with the boiling point, surface tension, viscosity, and vapor pressure. Explain what happened to the boiling point if we have the strongest intermolecular forces. Okay, and you are able to use phase diagram, CO2 and water phase diagram, to solve the problem related to the H2O and CO2. Okay, first, molecular comparisons. From here, we learn from chapter 1, gas, liquid, and solid. So the conversions of state of matter from the gas to liquid, this is what we call we cool or compress or undergo the condensations process. And then from the liquid to solid is a freezing process. Means that we cool the water here, liquid. Okay, and then from solid to liquid, heat means that heating or melting. While from the liquid to gas, we call it as a vaporization process. Okay, so this is a basic theory or concept that we have learned during chapter 1. The process gas to liquid, liquid to solid, and solid to liquid, liquid to gas. Okay, as you can see from gas, the molecule is far to each other, right? So when far to each other, to turn into liquid, it need to form a bond. Right? So when form a bond, undergo condensation reactions. Condensation reactions is the enthalpy or release the heat to form the new bond. Same goes with the liquid and solid. Liquid and solid, the molecule quite far, but when turns to solid, it near to each other, it's compact. So that means it's also release heat in order to form bond. Okay. From solid to liquid, this is broken the bond. We break the bond, become far to each other. And liquid to gas as well, we break the bond even far to each other. So this process, reverse process here, we absorb the absorb the heat, means the endothermic. This is exothermic. Enthalpy is negative, enthalpy is positive. Okay, that's the molecular comparison, state of matter. Okay, from this gas, liquid and solid, also we learn the properties. Okay, here are the properties 1, 2, 3, 4 for comparison. Gas, liquid and solid. In terms of volume, gas, we assume volume volume is for the gas it follow the container. If we put in triangle or rectangular shape of the gas, then it follow the container. And for liquid, assume a shape of the portions of container but not the volume. Liquid also follow the container. Liquid can flow, right? So it follow the container. Even though they have the same volume, it follow the shape of container. Even though this is 2 liter and 2 liter, same volume, the shape of the liquid follow the container. Solid is retain own shape lah, because solid like ice is in ice cube lah, you cannot change the shape. Okay, in terms of compressibility, gas you can compress, like balloon we can compress a balloon, right? Liquid slightly compressed, and liquid is slightly compressed, solid is incompressed. Then in terms of diffusion, gas occur rapidly while the liquid slowly and solid extremely slow. Okay, for the flow, gas flow quickly or rapidly, like same like the liquid also can flow, but for solid does not flow. Remember, flow in terms of you see you try to pour a water 1 liter of water into a basin, and then you observe what happened. It can flow, right, for the liquid, but if solid it can't flow. Okay, that's the comparison, molecular comparisons between solid, liquid and gas. Now come with the intermolecular forces. Okay, intermolecular forces is the molecule with molecule, like CH4 with CH4. This is intermolecular forces. Between CH4 and C4, they have intermolecular forces. If intra in this molecule. Okay. So the intermolecular forces are much weaker compared to ionic and covalent. Covalent is the strongest compared to ionic. Covalent is the strongest bond compared to ionic bond. But these four intermolecular forces, we have ion dipole, dipole, hydrogen bond, and London dispersion. That 4 forces is weaker compared to ionic and covalent, these two. Okay, so when the substance melts or boil, the intermolecular force are broken. You can see example for sublimation process. Sublimations from solid to gas. You know, the structure, the molecule of solid is very close to each other, right? So when undergo sublimations, it will absorb some heat to break the bond and to form the molecule far to each other, gas. So for the substance melt or boil or sublimes or vaporize, these three terms, the intermolecular force are broken. So this is endo, means that enthalpy is positive. We absorb the heat. Okay, when substance condensed means that from condensed from gas to liquid. You try to draw the molecule or structure for gas and liquid, state of matter for gas and liquid, and observe what happened. What you can see from these two. Condense means that from gas to liquid, the intermolecular forces are formed. Means that we form a bond. Undergo the exothermic, which is the enthalpy is negative. Other than condense, they have other process like freezing. This is melting, like melting, boiling, and freezing. Freezing is bond form. Other than freezing, we have the depositions. Depositions is between solid to liquid. Freezing, so liquid to solid. Freeze. We freeze the water to form ice. Okay, and boiling point and melting point indicate the strength of intermolecular force. Always keep in mind the boiling point and melting point. How do we relate with the how do we know higher or lower? We relate with the strength of intermolecular force. Okay, if we have higher or stronger the force, means that higher body and melting point. Because in order to break the bond, in order to break the strongest bond, we need higher energy. So higher energy, higher body and melting point. Always relate with the intermolecular forces for the melting and boiling points. For just now we look at for the covalent, right? Covalent bond.
Miss.
Where do I miss just now? Where do I stop just now? Lagging. Well, at
Boiling point.
Miss, your slide
One
is
point.
disappear.
Alright. Where did I lagging just now? Boiling point, right?
Yes, Miss.
Yes.
Okay. So when we talk about boiling point, please keep in mind to relate with the intermolecular forces. For the alkene average, low melting and boiling point, but when we compare between methane, one carbon with let's say butane, they have difference in different in terms of intermolecular force as well as the boiling and melting. Okay, that's the introductions of intermolecular forces. Now we look at one by one the types of intermolecular forces. The first one is ion dipole. Okay, ion dipole is between ions and molecule. Example of ions is Na plus Cl minus. This is ion. So between the ions, they have the ion dipole forces. Okay. And number two, molecule like molecule water. Water is molecule. Water cannot split. But many of you split this water. We have learned how to write the net ionic equation. Molecule cannot split. Insoluble cannot split. But most of you split this water. I don't know why. Okay, second, dipole force between molecule and molecule. Normally same molecule like BF with BF with BF. This is same molecule. Number three is a hydrogen bond. Hydrogen bond is quite special because very easy to detect the hydrogen bond. As long as you have hydrogen that bonded to F, O, N, that means they have hydrogen bond. Okay, and number four, London dispersion force. London dispersion force example between AR. I can say that all these substance here, they have London dispersion force. But you need to choose the strongest bond. Let's say in between BF molecule. So BF, we know they have they have a small amount of London dispersion force. But what kind of force is dominant in BF? We have the table on how to detect. We have the table on how to identify or detect the intermolecular forces. Okay, I show you after this. Okay, first ion dipole. This is 4 types of bond. We go one by one. Ion dipole force exists between ions and partial charge on the end of polar molecule or dipole. Example, NaCl in water. So between Na plus ions, they have water, right? Water molecule, surrounded by water molecule. Okay, so Na plus will attract to the O2 lah. O2 minus here. H2O, they have O, H, and then partial negative, partial positive, partial positive. So partial negative will attract to the positive Na. If partial positive H here will attract to the Cl minus. This is what we call the ion dipole force. So the ion dipole force depends on the magnitude of the attractions. Attractions of ion dipole force depend on number one, on charge. Let's say we have different charge here between Na plus with Cu2 plus. So which one is the highest charge? We have the highest magnitude of ion dipole. Okay, number two, magnitude of dipole moment. Dipole moment's value, if we have dipole moments higher, delta positive, delta negative higher, which means strong. Delta positive and delta negative means that stronger the attractions, magnitude of attractions. Okay, from here is the comparison. Ionic bond is stronger compared to ion dipole, and ion dipole is strongest compared to dipole. Okay, this is the ion dipole. Na plus with H2O molecule, they have positive, negative, and negative will attract to the partial negative will attract to the positive. Here is Cl minus, so that the partial positive will attract to the Cl minus instead of negative, partial negative. So delta positive, delta negative here are the dipole moment.
Can you go up a bit, please? Thank you. Yeah.
Okay. Okay, next is dipole. Okay, dipole is between the molecule and molecule. Normally, same molecule like BF. BF molecule is BF molecule. Okay, how to check the BF? How to identify BF is the ion dipole. Okay, now we see the table here. Okay, please focus this. There are few slides before we stop. Alright, this flowchart. Okay, let's say I took BF. Okay, BF molecule. So we check either they have ions in BF molecule. They have ions in BF molecule or no. BF is ions or molecule? No ions, right? BF.
Molecule.
Okay, so if molecule, then you go to the left hand side here, no. Okay, and then you check BF, is this polar? How to check polar molecule? So to check polar molecule, you try to draw Lewis structure. Lewis structure, B3, boron is 3, F is 7, so total is 10. Then you draw BF 2, 8, 10, right? So 10 plus 1 lone pair here. Okay, lone pair means that they have non-symmetry. Non-symmetry is polar, means that BF3 is polar. So we go to yes. Okay, yes, then check. BF, they have hydrogen bond. Okay, how to detect hydrogen bond? Hydrogen bond, you see, is there any H in BF? No, right? If no, then it is dipole-dipole. So BF is dipole-dipole. Okay. Did you get it, class?
That system is just to determine like what type of attractive force it is, kan?
Yes.
Okay, yeah, thank you.
Okay, and we go to the next, the previous slide. Okay, here. Dipole-dipole. That's how we determine dipole-dipole for BF. Check the Lewis structure. Lewis structure, if they have lone pair, means that this structure is non-symmetry. Non-symmetry is polar. If polar means they have check the hydrogen bond. If they have hydrogen bond, then that means the force here is hydrogen bond lah. But if no hydrogen bond, this is dipole-dipole. Dipole-dipole is the strongest bond. Dipole-dipole is the okay. Ion dipole is strongest compared to dipole-dipole. So hydrogen bond is strongest compared to dipole-dipole. Hydrogen bond is strongest. So if they have hydrogen bond, then you need to choose hydrogen bond, not the dipole-dipole. But now we BF we have dipole-dipole. So the BF is dipole. Normally exists between neutral polar molecule. This is very important. Highlight this point. Molecule that polar, neutral polar molecule. They have the dipole-dipole forces. So dipole-dipole is weaker compared to ion dipole. The ion dipole is strongest. Okay, this is the molecules. Looks like we have BF just now. BF attract to BF, partial positive, partial negative. So in this dipole-dipole, they have the attractions as well as the repulsions. Attractions greater than repulsion. So the partial positive attract partial negative more higher compared to partial negative repel with partial negative, or partial negative positive repel with partial positive. Repulsions means that between positive, positive, or negative, negative. But attractions positive and negative. Right? Female and male, they have the attractions. Where do we need to? Okay, I stop at this slide lah. Okay, we continue next slide. We continue next class. Dipole-dipole forces in terms of molecular mass and the dipole moment. Alright. Okay, so that's all for today.
Miss,
Yes.
so the order from the weakest to the strongest is dipole, hydrogen, ion, and ionic.
Okay, the weakest is London dispersion force.
Oh,
Okay, the weakest one. Okay, after London dispersion force, and then followed by dipole-dipole. Okay, after dipole-dipole, and then ion dipole. After ion dipole, then only hydrogen bond. Hydrogen bond is the strongest. But if we compare with covalent and ionic is the strongest compared to these four. Is that clear?
yes, Miss.
Alright. London dispersion force is like weak van der Waals force. Same thing, weak force. Then we have the dipole-dipole and hydrogen bond and ion dipole. Okay, any more questions, class? Where is the form here? Attendance. Wait time. Okay. This. Right, this is your attendance form. If no questions, then I stop at this.
Miss,
Yeah.
can I ask about chemist test to date? Is there any chance the date can move?
Wait, let me stop the recording first.
Sorry.
Okay. Alright. For your question, the other class also mentioned same thing. They want to extend the date of chemistry test, chemistry 2 test. They come up with the what we call the what um apa panggil apa tau memorandum.
Memorandum.
Yeah, memorandum. They sign. They got all the signature from their class and go to Dean TFS. I don't know the result today. Petition boleh lah. Because they try to ask for extend test 2 into the others date like 15 August, right? Like, as we planned earlier, 15 August, but 15 August is we cannot make it on 15 August due to the Perak Tower, isn't it? That's why coordinator has changed the date into 7th August. But for you, if you want to try, you can do the same thing. I know this week quite tough or quite hectic because lots of assignment, reports, right? And even you have two tests in one day, isn't it? On this 7th August.
Yes.
Try to approach our dean. Somebody as a representative go to the CFS office, try to ask. If you lucky, then you got. But for now, I nothing we can do. We just follow the flow, and I try to make extra class. That's the effort. That I can make for you lah. Now it's up to you. Now it's your effort lah to give, to see what's the result later. Okay, that's
Thank you, Miss. Bye bye.
okay. Any more questions, class?
No.
Okay, try buat bagi petition tu. Kalau you lucky, you dapat lah kelulusan. Cubalah, kita kan usaha kan. Mana tahu dapat. Saya ada juga tanya, tapi biasalah sebab saya bukan ada authority untuk change the date for test 2 because we have a few people in charge this chemistry 1. So I tak ada authority untuk bagi confirmation. For now, I just follow what we have discussed and what is given from the management. Right, sekarang dah pukul 8. Saya nak bagi tahu you banyak lagi, saya nak cakap lagi, tapi sebab pukul 8 ni kan dah lewat ni. Tomorrow lah. Okay. I dah stop.
So, Miss, regarding the petition form, is it done by someone or?
You lah jadi representative. buat tu.
I see. Alright, thank you, miss.
Why?
Nothing, miss.
Are you okay, Judah? What's wrong with you?
I'm okay, miss. I'm okay.
Your test ones. Okay. Have
I
you
need
checked your
to,
test one?
yeah, I need to keep up. I'll come back soon.
Thank you, Miss. Bye bye.
Bye, Gita. Okay, you may leave if you want. Is there any questions, class?
So, miss, for the tester, it will be
Hmm?
more complicated than test one, right?
No. I can say no. I can say that test two is more loosen compared to test one. Loosen a bit.
Okay, miss. Thank you.
Okay, bye.